Hello and welcome to Lab 3 where we go over circuits. I'm Carson Lawler, and for the physics principles that we're going to be discussing today, doing circuits, voltage differences, and capacitors, as well as the basic concepts of resistance, current, and voltage. Now, here's what we got for the round trip kind of circuit where we took the voltage measurements at each point. And so in the graph, so for this is like A to B, then B to C, C to D, and so on. And you'll notice that it kind of loops back around back to A over here, and that this value of A is basically equal to this value of A, which shows that, indicates that the net voltage difference is 0 across the circuit. For the calculations, like I said, the difference between all the charges sum to 0. And also another observation is that when you switch the parts of the voltmeter, then it changes to the negative or the inverse of what the previous measurement was, but it's still the same number. And then for the RC calculations, the charging constant, basically, we had a lot more data than this, but just for brevity, I'm selecting the 0.3 amperage light bulb. And so the capacitor had a capacitance of 1 farad and initial voltage of 2.5 volts, and from that we're able to calculate that the R1 over RC is equal to 0.12, or 12 over 100. And now what if there was no resistor? What if it was just the wires and we kind of just plugged it in? And, obviously in our model, since it's 1 over RC, and if R is 0, then it would mean that it's an infinite amount, so that it would charge infinitely fast. But that's not how real life works. In reality, it's still significantly faster than when we had the other resistors attached, but the battery and the wires still do have some small resistance, and it made it so that it charged faster, and faster than what our initial charges were, but it's definitely nowhere close to infinitely fast, which was 11.14 seconds, which is kind of slower than I thought it would be, but In conclusion, circuits and capacitors have non-constant flow. It's not a steady state operation. And if you take the observations, you can find a lot of interesting factors, which, most of which are pretty much invisible to us humans since we can't directly see electricity. And, tells us just kind of the movement of electrons. All right, thank you. Tried to keep this one short, and I'll see you next week.